Now that we know what a logarithm is, we are going to use that knowledge to simplify logarithmic expressions. Let me give you a few examples. If we see the expression log to the base 5 of 125, that means to find the exponent of 5 that yields 125. That is, we're thinking 5 to what exponent gives us 125? Well, because 5 cubed is 125, the log to the base 5 of 125 is 3. So remember, logarithm is exponent. Log to the base 3 of 3 means to find the exponent of our base 3 that gives us 3, right? 3 to what is 3? Well, that's 3 to the 1 is 3. Therefore, log to the base 3 of 3 is 1. Log to the base 49 of 7 means to find the exponent of 49 that gives us 7. And so we might have to think about that one, right? 49, how does it relate to 7? If I take the square root of 49, I get 7. And the square root as an exponent is 49 to the 1/2 is equal to 7. Therefore, the log to the base 49 of 7 is 1/2. Now, when is the log to the base b of x undefined? Remember, we talked about that the argument, that is the value of x, had to be positive. And recall that when we raise a positive real number b to any real number, the result is always positive, right? B to the x is always positive. When we think about the graph of the basic exponential function, our output value is always a y value that is positive. Therefore, the input of the log has to be positive. So the log of a negative number and actually the log of 0 is undefined. And how would I know that? Let's consider this expression, log to the base 3 of negative 9. What I'm thinking to find that answer is to think about what is the exponent of 3 that gives me negative 9. But when I raise 3 to some number, I'm never going to get the negative 9, right? 3 squared is 9. 3 to the negative 2 is 1/9. There's no way that I can get a negative 9, so this would be undefined. So I want to simplify some logarithmic expressions in this example. The first one we have is log to the base 7 of 7. So what you're thinking is, what exponent do I need to raise 7 to get 7? Well, 7 to the 1 is 7, so log to the base 7 of 7 is just 1. Log to the base 12 of 144 means what exponent do I need to raise 12 to get 144? Well, do you remember 12 squared is 144? The log base 12 of 144 is 2. Log to the base 8 of 2 means 8 to what exponent is going to give me a 2? Well, to go from 8 to 2, remember I have to take the cube root of 8 and I get 2. The cube root, written as an exponent, is 8 to the 1/3. So therefore, log to the base 8 of 2 is 1/3. Log of 100, remember that's understood to have a base of 10. It's a common log, which means what is a power of 10? That gives me 100. And 10 squared is 100, therefore the log of 100 is 2. Log to the base 14 of 1 means 14 to what exponent is 1? Well, do you remember that 14 to the 0 is 1? So therefore, log to the base 14 of 1 is just 0. The natural log of e to the 5 means, remember, our natural log is understood to be the log to the base e. So I'm thinking e to what power gives me e to the 5? Well, that has to be 5, right? E to the 5 is equal to e to the 5. So the natural log of e to the 5 is just simply 5. Log to the base 3 of the square root of 3. So this is asking me to figure out what is the exponent I need to raise 3 to get the square root of 3. But the square root of 3, remember, is 3 to the 1/2. So if I raise 3 to the 1/2, I get the square root of 3. Therefore, the log to the base 3 of the square root of 3 is 1/2. Log to the base 4 of 0 would mean 4 to what exponent gives me 0. But remember our basic exponential function, all of the graph for 4 to the x is above the line y equals 0. In other words, there's never a value that I can input into the exponential function to give me an output of 0. So this one is undefined. And if you remember the fact that the argument of the log must be greater than 0 for the log to be defined, then you can also use that information. Likewise, log to the base 5 of negative 25 would tell me to find what power of 5 gives me negative 25. But we just talked about that in the previous slide. There's no exponent that I can raise 5 to get a negative number, and so this also is undefined.